Hello. Yes. My name is Serhat. I'm from OLBRICHT Automation GmbH in Germany. We are a company that has been producing custom designed equipment for glass manufacturers since almost 50 years. The topic of the presentation is a comparison of several deairing methods for automotive glass. So how do I advance? The bigger one, okay. So when we're talking about deairing, there is several different methods, actually three main methods. And what we will do, we will go very quickly over them because I assume that everybody here is very familiar with the general laminating process. We will go through the strengths and weaknesses very quickly of each technology, and we will understand how we need to compare them correctly to be able to make the right choice. Because it is not, in a factory, it is not necessarily that one technology only will give you the best, the optimal solution. Okay, so let's start with the vacuum ring, which is probably the oldest technology. The working principle is quite simple. You have an oven with three different areas. The entry conveyor where you draw the vacuum, the oven itself where the edge is sealed, and then the exit conveyors where the vacuum is released. It is clearly there is some parameters that you need to hold to get a good deairing, which means that the deairing has to be done while the windshield is still cool. Then you heat the windshield up to a certain temperature. You keep the temperature for a full deairing and tacking, and then release the temperature only, release the vacuum only after the temperature has come down to the right level. Summarize, for the efficiency of this process, the type and the temperature at which the PVB is operating is critical. You need to have a complete set of rings for each different windshield shape and size. The rings can be silicone or EPDM, and again there is differences in price and differences in performance. The ring lifetime is limited depending on the usage. You can do 1,000 to 1,500 cycles. And the strengths. The biggest strength of vacuum rings is that they are scalable. You have small vacuum rings, big vacuum rings, and of course, because of this, if you don't need a very big production line, you are able to have a scalable investment, a low out-of-pocket investment. They are also flexible. They can handle almost any kind of windshield. There are some exceptions if your windshield has very sophisticated shapes like concave shapes or asymmetric shapes, which is coming more and more in the modern cars. You might have problems keeping a good vacuum. When there is connectors, in theory, it does work, but you need to perhaps clamp over the vacuum, over the connectors to make sure that you have a good seal. The weaknesses of the system, basically the main weakness is that it's a mostly manual operation. It requires a lot of labor. There is some automation opportunities, particularly at the unloading side, but they are not very big. The cycle time usually is high. It can go anywhere between 25 seconds to 60 seconds, and this is directly related to the size of the oven. So a bigger oven, a bigger investment does allow you to get a faster cycle, but usually it is not below 30 seconds. I haven't seen any oven that can do less than 25 seconds. The power consumption, it is convection, generally convection ovens. Per windshield, power consumption is on the high side. We talked about this. When you have complex shapes, it can be a challenge to have a proper fitting ring. Each different windshield will require a full set of rings. That means that the whole production, all the windshields inside the ring need their inside the oven need their individual rings, and these rings need to be stored and then brought back each time you have changeover, and this increases the time for the change of windshields. And finally, I think this is the last weakness. It is an important one. You have a high cost of energy as well as a high cost of consumables. When you need to replace the rings, particularly if you're going for the better, cleaner EPDM ones, every year you should be planning on a hefty maintenance budget. Oh, one more disadvantage, which hopefully doesn't happen very often, but it does happen. If the line stops, you need to empty the whole oven, or else you destroy the rings and or perhaps the windshield. So you need to plan for a storage location to get all the windshields out for temporary storage, and it can be sometimes as many as 300, 400 windshields in the oven. Second technology is the nipper roller. It's the nipper roller line is a bit of a strange line. It's a typical U shape where the windshields are traveling wings up. Here you can see, oops, back is this one. How do I go back? Can I go back a few slides? Little red arrow. Okay. Yes. So here you see the windshield, which uncommonly is traveling wings up inside the oven. And you will see in a few minutes why it's traveling in such a different way. We have two ovens, the Deairing oven and the tacking oven. And then we have two nipper rollers, which are at the heart of the system. And these are after the ovens. So what is happening, it's a two-step process. The first step is the deairing process, where the oven heats up the PVB and the glass to a certain temperature. Then the glass goes through the first nipper for the deairing process. In the second stage, the oven is heating the glass to a higher temperature in the PVB and preparing it for the tacking operation. And is it possible to click on this button to quickly show a video? It's not working. Okay, no video then. Okay, so as all systems, it also has strengths and weaknesses. The main strength of this system is that it is very fast. For standard shapes of windshields, it is possible to reach cycle times of around 14 seconds. For sidelights, this goes down to 12, 13 seconds. It is a system that can be fully operated. So from beginning to end, you do not need any operators to take care of the product. The energy consumption, by the fact that it is special tailored infrared lights that are indexable according to the size and shape of the windshield, is having a very, very low energy consumption. The maintenance cost, therefore, is very little because there are basically no consumables, very low consumables. The infrared lights are very long life. And the first-time yield is very high. The system can stop and go almost at the turn of a dime. And between windshield types or sidelights or sunroofs, The changeover is on the fly once you have the recipe in the system. And if you do have a stoppage, there is basically only 2 windshields inside the ovens, which can be buffered on the conveyors themselves. Now, the weaknesses, the major weakness is that the initial investment is relatively high versus the rings. It is not possible today to handle windshields with connectors, because basically you're going through mechanical squeezing out of the air, and this has the potential of damaging the connectors. The footprint is not necessarily longer, but wider. And it is very sensitive. Because of the speed of the process, you have to make sure that the glass matching, the PVB quality, the clean room operation are very, very good. The other thing is that when you have a company that switches to this process for the first time, it becomes a little bit awkward because you don't have the traditional transparency after the deairing process, because the glass temperature, or the PVB temperature, stays below 100 degrees. At the end of the second nipper, even at the end of the second nipper, the milkiness of the PVB doesn't go away, so it takes a different set of process performance indicators to find out how well the process has gone or not. And lastly, the vacuum bag, which is a very similar working principle to the vacuum rings. You have, again, entry conveyor, oven, and exit conveyor. The difference here is that at the entry conveyor, usually have, there should be a video here, maybe if you go over it. Okay, now let's go back. The videos are not working. So you have possibility of automation both at the loading and unloading side. And like the vacuum rings, the output is customizable. So depending on the size of your oven, you can have relatively faster cycles. Now, to go over quickly the strengths and weaknesses, the vacuum bag truly is a multi-purpose product. It can handle any kind of windshield with connectors, without connectors, complex shapes, easy shapes, sidelights, sunroofs, everything goes in the bag. As long as it can go in the bag, it can be de-aired. The cycle time can be short. I have seen vacuum bag lines with cycle times at 14 seconds, even lower, but this comes at a huge cost. They are fully automated and have probably, among all 3 technologies, the highest first-time yield. When you have the recipe in the system, the changeover is also almost on the fly. The weaknesses is obviously the investment initially is the highest. The energy consumption is also very large. And the vacuum bags, even though they are more resilient than the rings, also need to be replaced relatively frequently. And this brings a high cost of maintenance and consumables. The footprint of the line is the biggest of all. Here, you really do have to plan for stoppages, because if you have also particularly a fast line, you will have many, many windshields in the system that you would need to store in case of eventual stoppages. Now, and here we are coming to the heart of the presentation, is what do you really have to be watching out for when comparing the technologies as you need to make an investment. There is, of course, the investment cost, but it's not just what you pay to the supplier for the line. Because of the very different requirements of these lines, you need to pay attention to the power supply. Do you have enough power in the factory? Do you need to build additional transformer, additional power units? Storage, we talked about the anticipating stoppages, having enough space to store the windshields. Is there any add-on automation that has to be put in that is not included in the price of the equipment? When you're talking about labor, you need to consider the first-time yield, because if the first-time yield is low, if you need to put clamps on the windshields, if you need to, for instance, wipe the smudges of what initially seemed like a good idea to buy cheap silicone rings, but then you need 2 people at the end of the line to clean up the windshields. These are all additional costs that might not be considered when you make the investment decision. And finally, you need to really take a close look at what it will cost to run the line over the years. Now here I have, for the past year, we've been talking to a lot of producers. We've been receiving their data, and I was able to make some averages. The companies were willing to share their information on condition of anonymity of the data. So here you don't see information from any single producer, but it's an average. And what we're doing, we're comparing the ring, the nipper, and the bag, and we compared it as a cost per 1,000 windshields. So we took the 10-year investment period or depreciation period, and we calculated based on 3-shift production what it would cost, what would be the impact of several parameters. So the first one we're looking at is investment. And here you see that the biggest cost when you're talking about per unit windshield is for the bag. The nipper and the vacuum ring are actually very close to each other. And the main reason for this is the very wide difference between the cycle times. I mean, by the time you produce one windshield here, you've got 4 out in the production floor. The second parameter is labor cost, and here we've taken European labor costs, but we can redo the calculation with labor costs from any other region. And not surprisingly, the ring is here the highest. There is a small difference between bag and nipper, which is mainly due because of the fact that you need, even though it is a fully automated system, both of them you still will need some operators in real life, but of course much, much less than what you have in the ring. Maintenance, okay, this is a picture of the rings, and these rings have to be changed every once in a while, and then between each production run. And here is one of the points where you've got, again, a huge cost difference. In the nipper line, there is hardly any major component that needs to be changed frequently. But for both the ring and the bag, you have up to 100,000 euros of maintenance and consumable costs per year. And lastly, the cost of energy. And again, it's always calculated on a base of 1,000 windshields. Very high cost for the vacuum bag. Not so high with ring, but the lowest is for the nipper line. Now, when you put all of these together, one thing that is really striking is that the investment cost, which is shown in green, is actually so small that it nearly becomes negligible when you compare it to energy and labor. Now, we have, I think the next slide is, okay, the one after this is a small interactive exercise, but what is, to be able to make the right decision and not just looking at the price tag of the equipment, you really need to know what type of products you will be producing in the short term and mid-term, because some products will work with some lines and some won't. Also, your automation goals. Can you live with a fully manual production, or do you need more and more automation? And of course, you need to look at the other costs that are not necessarily apparent at at first sight. So can we see if, can you click yes or no just so that we test it? Okay, then can you click back here to the home button? This one here? I think, okay, we're good. So this is a small interactive program that we wrote and I can share with you. It's a rough idea to guide you into what you would need possibly. We have a more detailed exercise where we can actually input the real costs that you have for labor, energy, investment, and so on. But here, what we will do is, it's a series of questions that lead you down a path. And the first question is whether you will be producing glasses with connectors. Now, I'm not sure if there's any automotive glass producers amongst us. No? So I will say, yes, we will produce glass with connectors. Next question, are we allowed or can we accept fully manual operation? In this case, let's say no, because we have an automated factory and we cannot have fully manual. Next question would be, what is the most critical cost element? Is it the labor portion? Is it the energy? Is it the capital expenditure? And here, let's, who wants to choose? Anyone? Let's say energy. And finally, what kind of volumes do you expect to have every year? Less than 1 million units, between 1 and 5, or over 5 million units, which would be a really, really big factory. Let's go with high. And the system here tells you, okay, considering what you have told me, which is you will produce windshields with connectors, manual production is not acceptable, your energy cost is a decisive cost in your system, and you have high production output, the system recommends that you need 1 or 2 vacuum bag ovens and 2 or more nipper rollers, with the caveat that you should try to keep the number of vacuum bag lines as low as possible to cover your needs, in this case, of the glass with connectors. Now we can, I think this was set on 25 or 20? 25. If anybody's interested, we can do a few more of these simulations or interactive tests separately. I think I've eaten up all my time. Can you just click here so that we go to the last slide? Okay, so summarize in just a minute. It's a good idea to have a checklist when you are planning to make a Deairing investment for windshields. Do you have your master plan? Do you know exactly what you will be producing? Capacities, the layout that you have. Then have you considered all the relevant costs, including the ones that sometimes end up being hidden under other headings? And the most important thing is that one size or one technology does not fit all the problems. The optimal solution often will be to have side by side 2 of these technologies. Never 3, but often 2. And again, we just a small reminder that we have a website coming up soon called nipperroller.de, where all these interactive tools will be available. And this was the end of my presentation. I'd be happy to answer any questions that you might have.
Thank you very much. Are there any questions? I have a quick question for you.
Sure.
With the 3 processes that you've talked about, one of the issues that we see, not so much in the automotive side, although it is present there, but in the architectural side, is the alignment of glass. Are any of these processes better to keep the glass aligned than another?
As far as I know, no. Well, if you don't have tacking after the clean room, the vacuum ring could be a problem, because at that point in time, you're just using the tackiness of the cold PVB to keep the glass together. And there's a lot of manual handling. In the case of the nipper, this is not so much of an issue, because as soon as it comes out of the clean room, and if the job in the clean room has been done properly, then you go into the oven, the first Deairing oven, where the PVB is brought up to temperature, well, the external glass temperature is around 60, 65 degrees. And most importantly, in the nipper line, you don't align, you don't reference, you don't square the glass through mechanical means. Because this not only brings the problem of misalignment, but when you touch the sides and you have PVB that is poorly trimmed, or even when it's properly trimmed, you introduce bubbles with the mechanical referencing. In the line that I've shown here, there is absolutely no mechanical referencing. The whole thing is working through the motions of the conveyors and the nippers. And likewise, in the vacuum bag, this is also the system where there is the least handling. Out of the clean room, it goes into the bag draws the vacuum, and it in essence imprisons the two glasses. So the answer to that is, in the vacuum ring, you can have problems. It is the highest likelihood of problems, but with the nipper and the vacuum bag, not so much.
Thank you. Any other questions? We have time for a quick. Okay. If not, thank you very much for your presentation.
Hi there. Did you like what you just saw? If you did, why don't you like the video, drop us a comment below, and share the video as well, since GPD is all about sharing. And to receive more videos in future, subscribe to this channel, and don't forget to click the bell icon. Ciao.